What if your AI assistant could finish a work session, look back at everything it just did, clean up its memory, notice what it got wrong, and prepare itself to do better tomorrow? Anthropic's Dreaming feature for Claude is basically a background process that helps clean up and organize memory. Instead of only responding in the moment, Claude can review past work sessions, sort through old notes, and reorganize what it remembers between sessions. The idea is simple. An AI agent can take what happened in previous sessions and use that history to improve how it remembers things in the future, even while the user is offline. This chart shows how AI assistants have evolved. Standard chatbots answer right away, but they usually forget everything when you close the tab. Standard agents try to solve this by saving information into long-term memory, but that creates a new problem. Over time, the memory can fill up with messy notes, duplicate instructions, outdated preferences, and conflicting details. This timeline shows how memory buildup can hurt longer projects. On day 1, the memory is clean. By day 7, it has started saving useful preferences. But by day 21, that same memory can become a problem. Notes keep getting added, but old ones are not always removed. Eventually, the AI may have old information that no longer matches what is actually happening. In practice, this can lead to repeated mistakes. For example, if a developer switches from Supabase to RevenueCat in week 2, the agent might still try to use Supabase in week 3 because it is reading old setup notes from earlier in the project. This shows why simply giving an AI a bigger memory does not automatically make it more reliable. Without regular cleanup, a bigger memory just gives the agent more space to store confusing or contradictory information. This diagram breaks down the 3 phases Anthropic built to help solve this problem. A dream job is a background task that runs between sessions. It reviews the existing memory, removes outdated preferences, and combines duplicate notes into clearer, higher-level insights. Looking closer, a dream only needs access to the target memory store, but it can also review up to 100 past transcripts to find repeated patterns. More advanced models then run this reflection process in the background and create a completely new, reorganized memory store, instead of just making a small update. The pre-dream context shows an agent weighed down by messy notes, duplicate rules, and conflicting authentication flows. The dream pipeline cuts through that noise. In the post-dream context, those conflicting notes are replaced with one clear takeaway. The authentication flow is now exclusively RevenueCat. By cleaning up its notes, the agent helps make sure the next session starts with clear context. Instead of starting the day with old baggage, it begins with a cleaner understanding of the project. Because letting an AI edit its own memory can create risks, dreaming is designed to be non-destructive. The original memory store stays unchanged inside a read-only container. Claude creates a separate output store, which gives developers a chance to review the cleaned-up memory before using it in future sessions. Developers also get more control over the process. Through this configuration panel, they can pass custom instructions directly into the pipeline. That lets them steer the reflection towards specific project needs, such as updating architectural diagrams or focusing on certain parts of the project. However, persistent memory also introduces a new security risk: memory poisoning. If an agent processes untrusted input that contains a hidden prompt injection, bad instructions could end up being written into memory. To reduce this risk, Anthropic recommends using read-only memory stores for important reference material. This helps prevent the agent from changing core information that should stay fixed. As AI moves from short, temporary chats into longer, ongoing workflows, strict memory boundaries are becoming one of the most important security layers for agent-based applications. This kind of memory maintenance becomes even more important in multi-agent systems, where one main coordinator assigns work to several specialized subagents. If the coordinator is working from outdated memory, it may send the wrong instructions to every agent underneath it. A single bad note can affect the entire workflow. Reliable, well-organized memory is one of the biggest bottlenecks for these systems. Without it, the coordination needed to scale multi-agent work over long projects starts to break down. This graph shows the rising length of tasks that AI models are expected to handle on their own. In 2023, a typical GPT-4 interaction lasted about 4 minutes. By 2026, models are projected to handle much longer independent tasks, such as kernel design, running for 12 hours or more. Anthropic frames dreaming as practical infrastructure for memory maintenance. It is not a system where the AI secretly retrains itself. Instead, it is a reviewable cleanup process that helps keep an agent's memory useful, organized, and safer to work with. Solving context decay helps AI assistants stay consistent across projects that last weeks or even months. Instead of starting from scratch every time or dragging messy old notes forever, these agents can review their work, clean up what they remember, and prepare for the next task.